Hello, and welcome to another edition of the Daily Bolt with your host, Dr. Jeff Tilley. Today's topic: fortunately, the laws of physics can't be changed. Sit back and relax and enjoy today's edition of the Daily Bolt. Okay, so it is September 3, 2019. And yes, this is another podcast about Hurricane Dorian, but it's more importantly about what's happened to Dorian over the last 24 hours. Dorian spent most of the last 24 hours not moving a whole lot. It has drifted from the east side of Grand Bahama Island to the west side, and it's a little bit farther offshore, and that's partly also due to the fact that Grand Bahama Island on the west side slopes a little bit to the southwest, but it is still very close to Grand Bahama Island after 36 hours since it first made landfall on the eastern tip of Grand Bahama. And it's been a very rough 36 hours for the residents of Freeport and other inhabitants on Grand Bahama Island, including any tourists that happen to be trapped there. So our hearts and prayers go out to them. They still are dealing with lots of flooding. They still are dealing with lots of wind, especially now more on the west side of the island than the east. But the whole island is still really under the gun in many, many ways. However, Dorian has finally started to move, and it has started to make a turn in its movement. It's moving as of about 11 a.m. Eastern Time, 2 miles per hour, which is still not fast, but it's faster than being stationary, which was the case yesterday. It's moving 2 miles per hour now in a solid northwesterly direction, and it's about 100 miles off the east coast of Florida. The expectation is that it will stay offshore in terms of its eye wall and its eye at this point, because it has started to make the turn. As it gets farther and farther north, it will start to become more and more under the influence of a large-scale weather system coming into the northeast and mid-Atlantic states in the U.S., which will start to give it a little bit more of a push from the upper atmospheric winds towards the north, and then eventually a turn towards the northeast. This track will still keep it fairly close to most of the U.S. East Coast. So the East Coast, in particular the southeast coast, is still going to be substantially affected by Dorian. There are some showers and a thunderstorm or two in the outermost bands of Dorian that have been impacting the east coast of Florida for some time now. They're rather scattered. They're not as well organized this morning as they looked yesterday. As Dorian gets closer to the coast, it will certainly have some of that activity pick up a little bit. The winds. This is the other key thing about what's happened to Dorian over the last 24 hours, which we'll talk about once I'm kind of through with the synopsis. Tropical storm force wind gusts, at least, are now being reported up and down the east coast of Florida. Most of the steady winds that I've seen in the last hour have been anywhere in the neighborhood of about 22 to about 28 miles per hour, which is below tropical storm force for steady winds, but the gusts are certainly into the tropical storm force category. And as Dorian continues northwesterly, it will get closer to the coast, and we may see steady tropical storm force winds later today along parts of the east coast of the Florida Peninsula, as well as with the increase in shower activity. So what's been going on the last 24 hours? Well, first of all, In addition to the motion and the synopsis aspects I just talked about, Dorian's winds have decreased rather dramatically. No longer is Dorian a roaring 185 mile per hour Category 5. It is now down into the 110 mile per hour range, where it is expected to basically stay intensity-wise as it continues its journey along the U.S. southeast coast. And one of the reasons for the weakening comes back to thermodynamics, which is a branch of physics, and it's something that I hinted at a couple of days ago in a previous podcast. That is the fact that hurricanes tend to leave colder ocean waters in their wake. They bring the circulation of the atmosphere tends to allow for a phenomenon called upwelling in the ocean, where cooler water from deeper layers below the surface gets brought up to the surface. And that cooler water then can stay on the surface for a while before it has a tendency to sink back down. There's a lot of mixing that occurs, and the temperature structure in the upper ocean becomes closer to a bit more uniform. And the thing is, with Dorian basically being quasi-stationary for almost a 24-hour period, maybe a 1 mile per hour motion at the most, it brought up a lot of this cold water basically right underneath itself. And as I've mentioned before in previous podcasts, one of the main heat engines for a hurricane is warm ocean water. It helps fuel the convection. It provides a source of moisture. And when you cool that ocean water, it tends to put a brake on the convective thunderstorms that make up the eye wall of a hurricane and help drive its strengthening and its winds. The more upwelling you have, the more likely you're going to start taking punch out of the hurricane. And that is precisely what happened in this particular case. And at the same time, as it's weakening, then you also have the tendency for less organization and for the convection to spread out. And that's also due to the upwelling. It's looking for warmer waters to be able to tap to keep the thunderstorms going. It's not really that it has a mind of its own, it's just that's how the thermodynamics work out to keep the system being as efficient as possible. Nonetheless, as the thunderstorms get farther away from the center of the eye, that's a larger area of air that you have to move to keep the circulation, the cyclonic or counterclockwise circulation of a hurricane going at lower levels. And now we come to the second physics principle that's involved, something called the conservation of angular momentum. You might know this better as the ice skater effect. If you've ever watched competitive ice skating, as the ice skaters start to do a spin, they bring their arms in close towards the center of their body, and as they do so, they start to spin faster and faster and faster and faster. This is this physical principle of conservation of angular momentum in operation. As the axis of rotation gets smaller and smaller, the angular momentum is conserved, and that allows for a speed up in velocity so that you spin faster and faster and faster. It works the opposite way as well. When the skater wants to slow down, he or she then starts extending her arms outward, and that allows for the spinning to slow down, and eventually the skater can come to a stop. So how that applies to Dorian and hurricanes is that as the upwelling produces cooler waters, the convection moves farther away from those cooler waters, and the amount of air that has to be moved increases, and the axis of rotation increases, meaning that since the axis of rotation, which is part of the angular momentum equation, increases, the velocity has to decrease. And that allows for a decrease in velocity. Now, this is a bit of a simplification. It's actually a little bit more complicated than this, and anyone who studies hurricanes who's hearing this podcast would probably chastise me for oversimplifying it a bit. But this podcast is meant more for non-specialists, and so it's basically the best way to simplify what's actually going on in terms of the decrease in the speed. However, there is now that Dorian is larger, its hurricane force winds now extend out to about 60 miles away from the center, as opposed to about half that when it first came into the Abacos a few days ago. So you have a broader area of less intense winds as opposed to a more concentrated area of more intense winds. That still works from an angular momentum perspective. And so it's still scientifically correct. Even though everything that's going on with the hurricane and the eye wall and the convection, again, is a little bit of a simplified picture for my audience. Anyway, regardless, Dorian's strength is unlikely to return, at least not to the extent that it was before it came into the Bahamas. And the reason for that relates to this other factor that will be coming into play, which I've talked about also on previous podcasts, that being shear, or an increase in vertical winds, an increase in wind speeds in the atmosphere surrounding the hurricane as you go up, what we call wind shear. And that tends to tilt the thunderstorm activity. It tends to allow for the system to be in a less efficient configuration from a thermodynamic point of view, because you're tilting the thunderstorms, the convection that drive the eye wall, and it changes the circulation, elongates it a bit. It makes it more difficult for the hurricane to be as efficient in converting the thermal energy from the ocean water and the surrounding atmosphere into an actual motion or wind speed. And so as Dorian gets farther and farther north, it gets closer and closer to the mid-latitude westerlies, where you tend to have more of this vertical shear in the wind as a matter of course. And so even though the ocean temperatures will be very warm now that Dorian is moving away from the Bahamas again into open water, it's going to be fighting this shear. So there may be a little bit of intensification, but I would be extremely surprised to see it get back up to a Category 5 status or even a Category 4 status. I think it's going to most likely maintain itself where it is, which is still at 110 miles per hour, nothing to sneeze at or take casually. But I think we've seen the strongest of Dorian from a wind perspective. Now the question is, how much storm surge will there be along the U.S. southeast coast, which is again a function of just how close it gets. Certainly, as I mentioned in yesterday's podcast, beach erosion is almost a certainty, and there's going to be some winds strong enough to blow some things around at the least. It may get significantly worse if Dorian ventures closer to the coast than expected. That's it for today's Daily Bolt. Hope you enjoyed it. I'm Dr. Jeff Tilley. Good morning, good afternoon, good evening, depending on where you are. God bless.